when you solve a rational equation, you want to multiply the entire equation by the LCM of the denominators. When you do that, all of the denominators will go away. You will be left with an equation that is no longer a rational equation. So the way we want to solve a rational equation is by making it no longer a rational equation. Okay? So here, part A. We have 4 over x plus 2 equals 5 over 2x plus 3. We want to find out what the LCM of the denominators is. The first step in doing that is factoring each denominator. In this case, neither of them factor. X plus 2, 2x plus 3, neither of them factor. So we want to multiply this entire equation by the LCM of the denominators, which is x plus 2 times 2x plus 3. So we have to realize that when I multiply this right here, the x plus 2's cancel, correct? So I have 4 times 2x plus 3 equals, when I multiply this by x plus 2 times 2x plus 3, the 2x plus 3's will cancel, so I will have 5 times x plus 2. So now we have an equation that should be relatively easy to solve. Distribute the 4, we get 8x plus 12 equals, distribute the 5, 5x plus 10. Subtract 5x from each side, we get 3x plus 12 equals 10. Subtract 12 from each side, we get 3x equals negative 2. So x is negative 2/3. And if you want to make sure you're right, you want to plug that back in up here. And if you plug that one in, I'll tell you, it works. Is there something you guys want to watch out for when you plug back in? You want to make sure that this number certainly does not make your denominator 0 here. Because as we all remember, denominators are not allowed to be 0. So do just make sure, that would be a good hint if you're right or not, make sure this number does not make either denominator equal to 0. That would be bad. Let's move on to part B. 1 over x times x minus 5 plus x minus 7 over x equals 4 over x times x minus 5. What is the LCM of these three denominators? X times x minus 5. So I want to multiply the entire equation by x times x minus 5. When I distribute this through, when I multiply it by this term, both parts in the denominator actually cancel. I'm left with 1. When I multiply here, only the x cancels, so I'm left with x minus 7 times x minus 5 equals, when I multiply here, everything cancels. I'm left with 4. So now, we have 1 plus, we have to FOIL these, x squared minus 5x minus 7x plus 35 is 4, which gives me x squared minus 12x plus 36 is 4. What type of equation is this? It's quadratic. How do you solve a quadratic equation? You get it set equal to 0. So subtract 4 from each side. we get this. I'm going to choose to solve this particular quadratic equation. Now that it's set equal to 0, I'm going to solve it by factoring. What two numbers multiply to be positive 32 and add to be negative 12? Negative 8, negative 4. Which means my solutions, x equals 8 or x equals 4. And you want to plug them back in and make sure that they do in fact work. Do both of those numbers work in this problem? I checked x equals 4. That one works. What about x equals 8? And you check x equals 8. It works as well. When you check x equals 4, you should end up with, I believe it was negative 1 equals negative 1. When you check x equals 8, you should end up with 1/6 equals 1/6. Both of those are obviously true, so they both work. So, that is how we're going to solve rational equations. Here, a carpenter can build a desk in 6 hours, another carpenter can build the same desk in 8 hours. How long will it take the carpenters working together to build one desk? We've done problems like this in the past. How do we set this up? This was a question on the final. What you want to do, let's call it carpenter A and carpenter B. Together we could call them the carpenters. Yeah. So, carpenter A. How much of the desk can carpenter A build in 1 hour? He could build 1/6. How much could carpenter B build in 1 hour? 1/8. So how much of a desk can they build when working together in 1 hour? 1/6 plus 1/8. That is how much the two guys will build working together in an hour. So we want to say how many hours, so multiply this by x, how many hours will it take to build how many desks? 1. So you have your rate. This is how fast the two of them will build the desk together, multiplied by the number of hours. That should be 1 desk. So, you want to say, if you want to put all of this in the calculator in one line, you want to solve for x, what you're going to ask the calculator for is 1 divided by 2 parentheses, 1/6 plus 1/8. Like this. That is going to give you a decimal. And we could just round to the nearest tenth on that one. How long will it take? They don't ask us to be specific on the rounding. So we got 3.4. So how long will it take them working together to build one desk? 3.4 hours. So, like I said before, we're going to have rational equations. That means you're going to have a rational expression on at least one side of the equation. We've worked on problems that had it on both sides. The last problem only had a rational expression on one side, but it was all numbers, so it wasn't really that difficult to work with. Now we have rational expressions on one side of the equation, and that's it. But the approach is the same. 5 over x plus 1 plus x over x minus 1 is 5. We want to multiply this by what? The LCM, which is x plus 1 times x minus 1. When we do that, we get 5 times x minus 1 plus x times x plus 1 is 5 times x plus 1 times x minus 1. Now, we have 5x minus 5 plus x squared plus x is 5 times x squared minus 1. Multiplying these binomials together is nice because we can recognize that x plus 1 and x minus 1 are conjugates. And when you multiply conjugates together, you only have to worry about multiplying the first and the last because the outside-inside multiplications will cancel. So then we have, on the left, we can combine some like terms to get x squared plus 6x minus 5. Then on the right side, distribute the 5 through, 5x squared minus 5. We have a quadratic equation. We want to get it set equal to 0. I'm going to move everything from the left side over to the right side. So I get 0 is 4x squared minus 6x, and then that's it. Now, since those 5s, that constant term canceled out, a somewhat troubling quadratic equation now looks pretty easy to deal with because we have 0 equals, we can just do a GCF, 2x times 2x minus 3. If 0 equals 2x times 2x minus 3, that means that either 2x must be 0, in which case x is 0, or 2x minus 3 must be 0, in which case x is 3/2. So these are my two options. Do they both work? You check 0, that works out. You should get 5 equals 5. If you plug in 3/2, you get what? Yep, 3/2 works as well. You plug that in, the left side becomes 5. So, you get your two answers. Again, be in the habit of checking them to make sure they work. So what are the solutions to the rational equation? Right jaw.